Hey, welcome back. Hope you had a great day. We're going to move on to section 2.8. Going to start talking about some inequalities. You've done inequalities in the past. So I'm going to start with simple ones where we're just adding or subtracting, multiplying or dividing. But I want to teach you a new notation. One you're used to seeing is called set notation or set builder notation, and I'm going to teach you interval notation. And it's just a different way. I like it better than using set notation. So today I'm going to use my knowledge of graphing inequalities along with the addition and multiplication properties of real numbers and learn a new notation called interval notation to use when solving simple inequalities. I'm going to set my pen here, which I try and do before, but I sometimes forget. So here we go. All right. What we've learned in the past is that an inequality may have no solution. An inequality may have an infinite number of solutions. Generally, there are more than one solution because you're picking up everything less than or greater than a particular endpoint. We have used in set notation open dots to indicate. Sorry, I thought I hit my highlighter. We have used open dots to indicate the greater than or less than symbol that doesn't include the endpoint. This would be no endpoint. We've used the closed dot on a number line for the ones that are inclusive or include the endpoint. Include endpoint. Okay. The notation we've used is called set notation, and it reads like this: all x's such that x is less than 2. All right, when we did this, when we graphed this, if we said here was 0, this is 2, we would use an open dot at 2, and then we would use a line to the left because this is the arrow is pointing to the left and the variable is on the left. All right, so that's how we would graphically display all x's such that x is less than 2. For all x's such that x is greater than 4, we would put a closed dot at 4. If this is 0, here's 4. We would put a closed dot at 4, and then we would go to the right with our line because our arrow is pointing to the right and our variable is to the left. Okay. The point about the direction of the arrow is the direction of the line only works when you have the variable on the left side of the inequality. So make sure you remember that. All right, here's our new notation. This is called interval notation. Interval notation. Okay, we're going to use a system of parentheses or brackets depending on what our equation says and the implication of the equation. All right, for symbols that don't have the equal sign underneath, like this one does, all right, greater than or just less than, but not the little equal sign, you're going to use parentheses. Okay? Right? This means that the endpoint is not part of the solution set. For symbols like greater than or equal to and less than or equal to, we're going to use brackets. Brackets. They mean different things. This one means that the endpoint is part of the solution. Okay? Now, we have to come up with a symbol so that we can include everything to the left or everything to the right, and that is the symbol infinity. Negative infinity means everything to the left is included, and you always use a parenthesis in front of the negative infinity when you use interval notation. This means that the line extends left forever and ever. All right, the word that the symbol that we use to represent everything greater than, that's going to be the positive infinity. Again, we're going to use a parenthesis, all right, and this means that the line extends forever in the right direction. When we write our set notation, 4 to positive infinity, we have to make sure we understand that we are not writing an ordered pair. This is an interval on a number line. This is an interval on a number line, not an ordered pair on a coordinate plane. This is an interval on a number line. Let's practice doing these. Let's write an interval notation and then graph. If I want all numbers that are greater than -5, that means -5 has to be my smallest number, all right? And I have an exclusive, or I don't have the little line underneath, so I need to use a parenthesis. My smallest number is -5, and I can go on forever off to the right. So if this is 0, here's -5. Hold on. Let me move it over so I have a little bit more room. Zero, 1, 2, 3, 4, 5. Here's -5. I'm going to have a parenthesis at -5 because I don't have a little equal sign underneath there. It doesn't include that endpoint. And then it's going to go off to the right forever and ever and ever. Example B, I have all x's such that x is less than or equal to 3. All right, so I'm going to pick my 0 point. Here's my 3. All right, everything has to be less than 3, so or equal to 3. So I have a bracket at 3, and that means everything to the left has to be included. Well, when we want everything to the left, we use a negative infinity symbol like this, and then we graph it. All right. The first letter C here, we have a range that has 2 endpoints. All right. So you just look at each endpoint separately. My smallest endpoint, or my smallest number in my interval, is going to be a 2. All right. Now look here. Will I use a parenthesis or a bracket? This symbol requires a parenthesis. So I have 2. And then I have 7. And this symbol requires a parenthesis. So if I am graphing this, here's 2, 3, 4, 5, 6, 7. Here's 7. I'm going to have a parenthesis and everything in between them. That is a parenthesis. I'm sorry, that looks so bad. The second letter C, I have all x's such that x is greater than -1 and x is less than -3. So I pay attention to my 2 endpoints. I have a -1 and I have a 3. Okay, what symbol is associated with -1? Well, that's just a less than, so I'm going to use a parenthesis. What symbol is associated with the 3? Well, that has the line underneath, so I'm going to use a bracket. If this is 0, here's -1, here's 3. I'm going to have a parenthesis and a bracket at 3 and everything in between, just like that. Why don't you try D and E and come back and I'll do D, E, and F with you. All right, welcome back. For D, we have a -2 and a 4. The symbol associated with -2 is going to have to be a bracket. The symbol associated with 4 is going to have to be a parenthesis. So if I go 0 and -2 And then 4, I'm going to have a bracket at -2, a parenthesis at -4, and everything in between them. E, my range is 3 and 5. It's less than or equal to, or both of them are inclusive here. So I have a 3 and a 5, and both of them have to be brackets. So if this is 0, here's 3, here's 5, and I have bracket, bracket, a line in between. Now F, they want us to graph all the real numbers. So this means it goes on and on forever, both in the right direction, and it goes on and on forever in the left direction. And we write this as negative infinity to positive infinity. This is how we depict all real numbers using interval notation. This equals all real. Okay? All real numbers. When we graph parabolas, we use this notation, all real numbers. All right, now we can solve inequalities as well, like we've done in the past. We're going to use the exact same techniques using the addition property. I can add the same number to both sides. I can add a positive number. I can add a negative number to both sides without changing the solutions or the value of the solutions. All right, the inequality looks different, but the solutions remain the same. This is what's going to help us solve our inequalities. Remember this tip. I'm going to highlight this whole center. It is easier to graph a solution when you have solved the variable to the left. Solve with the variable to the left, because that way your line goes, your solutions go in the same direction as your inequality sign. All right? Let's try a few. Okay. We have 7x plus 3 is greater than 2x minus 5, and the directions are solve, graph, and write the solutions in interval notation. I'm going to solve by subtracting 2x from both sides. All right, when I do that, I get 7 plus x is greater than negative 5. Now I'm going to add a negative 7 to both sides, and I get x is greater than negative 12. X is greater than negative 12. I need all numbers that are bigger than negative 12. So that means my smallest number that I can have is negative 12, and I have to go off to the right. So if this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here's negative 12. All right. I'm going to use a parenthesis here because my inequality does not have the equal sign part with it. And then it's greater than, so I want everything to the right. Whenever we use everything to the right, that means in interval notation we write plus infinity. Okay, negative 12 comma plus infinity. These are all numbers greater than negative 12. On number 2, I'm going to again move my variable to the left by subtracting 7x. And I get negative 1 plus x is less than 2. I'm going to add 1 to both sides. Oh, sorry, that looks bad. And then I get x is less than 3. That's set notation. So this means I want all the numbers that are less than 3. So if here's 0, here's 3. I want everything less than that. And this does not have an equal sign, so 3 is not included in the solution set. So I'm going to use a parenthesis. And when I have a line going on and on forever to the left, I use negative infinity. And then my ending point here is 3. And I use a parenthesis. All right, these have greater than or equal to signs, so you should recognize that we're going to use brackets. All right, we're going to use brackets. Again, I'm going to move my variable to the left by subtracting 3x from both sides. When I do that, I get 3 plus x equals negative 1. I'm going to subtract 3 from both sides, which is the same as adding a negative 3 to both sides, and I get x is less than or equal to negative 4. All right, I have a bracket. I have to use a bracket at negative 4, so I'm going to put 0 down, and here's negative 4. I'm going to use a bracket here, and I'm going to draw a line going on forever to the left. A line going on to get forever to the left means I have to use parenthesis negative infinity. Whenever you use an infinity, you must use a parenthesis. Must, must, must. And then my ending number is negative 4 with a bracket, because my symbol indicates that I need to use a bracket. Number 4, I'm going to subtract 7x. Again, look at your inequality. With the line underneath means I'm going to need to use a bracket. All right, I'm going to subtract 7x from both sides. I get 8 plus 3x is equal to 2. I'm going to subtract 8 from both sides, and I get 3x is equal to 6. This leads into our next discussion. I'm sorry, this is greater than or equal to, sorry. With inequalities, we can divide by a positive number, multiply or divide by a positive number without sorry about this. I'm going to try and save this because I've already recorded this a couple times. So if you don't mind, I'm going to just try and get you back to where you need to be. I apologize for this. Okay. My pen. Okay. I'm going to divide by 3, which says that x is going to be greater than a negative 2. All right. So here's 0, and here's my negative 2. I have to, I'm going to kind of reiterate a little bit here. We have a greater than or equal to sign, so that means I need to use a bracket. And everything has to go off to the right without end forever and ever. So we're going to get in interval notation, bracket negative 2, comma positive infinity parenthesis. All right, you notice that we divided by a positive 3, the last problem. This is because that rule, the multiplication property of equality / division property of equality, says that as long as I am multiplying or dividing by the same positive number, then my solution set will stay the same. My inequality may look different, which is what we want, but my solution set will stay the same. This helps us solve. For example, 4x greater than negative 16. We're going to solve it, graph it, and write the solution in interval notation. To solve this, I need to divide by 4 on both sides. Notice that I'm dividing by a positive 4, so I'm allowed to keep my inequality going in the same direction. X is greater than negative 4. This inequality symbol does not have the equals portion to it, so that means I'm going to use a parenthesis. All right? So here's 0, here's negative 4. All right, I have to use a parenthesis, and I want everything that is greater than negative 4, bigger than negative 4. There's a parenthesis, and then I go off to the right. Off to the right implies that I am going off to positive infinity, and my end point is negative 4, and there is my solution in interval notation. Here we go with number 2. This is going to combine addition and then multiplication or division. I'm going to subtract 4 from both sides because that is adding a negative 4 to both sides. And I get 2x is less than negative 16. All right, this is negative 12, like 12 reds. I'm putting down 4 more reds. I have a total of 16 reds. Okay, now I'm going to divide by this positive number, so my inequality holds in the same direction. X is less than negative 8. Okay, so I'm going to graph that. Again, I don't have the equal portion of this inequality. It's just less than negative 8. So here we go, 1, 2, 3, 4, 5, 6, 7, 8. Here's negative 8. I'm going to use a parenthesis. I want everything to the left of this because that's all the less thans. Remember, left is less. All right. So my interval notation, when I have a line going off to the left like this, that's indicating negative infinity to negative 8. My inequality says don't include that point, so I use a parenthesis like that. When we multiply or divide by a negative number in inequalities, we have to make one important flip. If you divide by the same negative number, highlight this, the same negative number, you must flip the direction of your inequality sign. Your inequality sign must be flipped. All right? Flip the symbol if multiplying or dividing by a negative. Flip the symbol if multiplying or dividing by a negative. All right, so we're going to solve, graph, and write solutions in interval notation. I have chosen to do fractions for this so that you can see the hardest examples, and then hopefully you'll be able to do the easier ones tomorrow in class. All right, here we go. I'm going to do a two-step method, There's a one-step method or a two-step method. I really believe that most of you use the two-step, so that's what I'm going to do. In order to solve this, this is a negative 3x divided by 4. I'm going to undo division, and so I'm going to multiply both sides by a positive 4. So I have negative 3x is greater than or equal to 24. Now I am going to divide by the negative 3. Now I am dividing by a negative number, which means that I have to, in order to keep my solutions the same, I have to flip my inequality sign. So this becomes x is now less than or equal to a negative 8. This is the solution that I'm going to graph and write in interval notation. So I'm going to start here at 0, and I'm going to find my negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Here's negative 8. All right. This inequality symbol says I must use a bracket. Everything has to the left must be included because my variable is to the left and my inequality is pointing to the left. And because of the equals part of this, I have to use a bracket at -8. Therefore, my solution in interval notation, whenever I have an arrow going off forever in the left, that's a negative infinity to -8 bracket. All right? All right, now with this one, on example number 2, a couple choices here. I can multiply every single term by 7, which is what I'm going to do. 7, 7, 7. These 7's cancel, and I have -2x minus 42 is less than or equal to a -28. Now I'm going to add 42 to both sides. And I get -2x is less than or equal to 42 minus 28 is 14. Now I'm going to divide by a -2. At this point, I must flip this inequality. So I have x is greater than or equal to a -7. Greater than or equal to -7. Here's 0, 1, 2, 3, 4, 5, 6, 7. Here's -7. All right. I want everything to the right of it. And then I want to use a bracket because this has the equal sign underneath. In interval notation, this becomes bracket -7, comma, positive infinity, like that. Okay? All right. These are the problems we're going to work on tomorrow. If you have a chance and you want to try and do a couple of them, feel free. If you didn't understand something, please feel free to watch it again. Don't flip your lid. Watch it again if you don't understand. It's okay. It's okay. It's okay. You can do this. Don't give up. Thank you for listening. Hope you have a good night. See you tomorrow. Bye.